Our next speaker is Kikumi Tatsuoka. She's a distinguished research professor emeritus from the Teacher College at Columbia University. That does not sum it up at all. There is a lot of history going back. I actually figured out that I met her son as well. He was working at CREST, and I think her roots go way, way back with CREST. And there is no way I can describe her, especially not in the male-dominated world of Star Wars, because there's no Master Jedi for her. So it is an honor to have Kikumi here. Please welcome her.
How to go to next page? Yeah, this one.
And right.
Oh, okay.
This was what they see.
And
this is what the next one
and
is.
then I have to hit this one,
Yes,
so that comes here. Okay. Hi, I'm Kikumi Tatsuoka, and thanks to Eva for inviting me here. And my title is How to Improve Students' Thinking Skills. I've been, doing research on this area for many, many years. I'm old, and I have created cognitive diagnostic methodology called rule-based method and Q-metrics. And the mechanism of cognitive diagnosis is we have to connect observed world, which assessment response patterns, to brain in our own brains, like thinking skills, cognitive processing skills, and knowledge, and typical item type skills. Those things are all done within my our brain, and those invisible variables are working in this black box. And here is item, response patterns there, and something mechanism we have to develop to connect brain's working and item observable information. And so I created Q metrics, or sometimes called incidence metrics, which is item times attribute metrics. And over here, attributes are all sort of thinking skills and knowledges. And here, next mechanism we have to create was, we have to create some, I call the Boolean descriptive function. We created it. And this function creates attribute patterns with ideal item score patterns. Ideal means it's not actual data, and it's generated through Q metrics from attribute patterns. So that if those ideal item score patterns, which students' response pattern is closest to one of these list of ideal patterns, then we right away going back to brain and say which attribute can do and which attribute cannot do. And that's mechanism. It's a little more complicated, but we could applied to small scale test to large scale assessment. And here. I'm sorry, I'm a little stupid in machines. And now, I was lucky, previous, NSS fund, two funds, good data set I found to pursue this, title. And one is analysis of, this is a state assessment. And also, I analyzed two large-scale teams are. And so that Broward County, Florida mathematics assessment is well-designed experimental designed, so that I was very lucky to have such a good large-scale assessment. And they gave students, 7th graders, pretest, and based on pretest scores, they classified the student into 13 different courses, and all depending on pretest scores. And the number is almost 15,000 students. So we have enough sample size. And then I decided to pick up out of, okay, that's data set. Top-notch student of pretest scores are assigned to algebra honor course. And the second group of high scores students are assigned to algebra advanced course. And then they divided into algebra and geometry 7th grade. So that geometry 7th grade's course is actually, it's not top notch, but in about 15 percentile student. And so it's a smart, good student, but not enough to be in honored classes or algebra courses. And that's the way they assign the student. And, hey, bastard. And this is, a line, but over here, and then next, we have to, develop attributes. Attributes are, I name it as knowledge needed in answering each item, and cognitive processing, attributes, and skill item type, attributes. And I used the same data set to analyze both data, TIMSAR and Florida, assessment. And the content, that's 7 attributes for content area, and 9 attributes are from cognitive process area, and 9 attributes are item type. And these are, okay, so here is the, rule space result. And I wrote everything in one page, so that. And here, most, purple part is geometry student. And 11 is honor student, algebra honor student, so that they are, top-notch student there. And 12 is algebra advanced student. And colored purple is numbers here, like, columns are diagnosed attributes, mastery probabilities of, group. And I colored purple, green, and brown to make it, see it clearly. If scores, attribute scores are more than 0.90, 900, so that is very high scores. And from, very left side is mean scores. And they have only 2 larger than, mean value of larger than 0.95. So that you can tell it's a pretty well distributed, attribute patterns. But those, the 7th graders, algebra kids, number of, the colored box are, they got the highest probability, or means, attribute probability means, and 12, 11, and honor student in the second, and advanced algebra advanced student are third. And from here, it's very obvious that algebra students, even though they are selected top honor student, but they are, behind geometry student. And moreover, geometry student, mastered two more, attributes, P3 and P10. And P3 is judgmental applications of knowledge in arithmetic and geometry. And P10 is quantitative and logical reading, such as less than or must or at least or so on. And 5 more, thinking skills. P2 is computational applications of knowledge in arithmetic and geometry. And P5 is logical reasoning. P9, management of data, control, executive control. It's very important to be, good president or whatever, managing it. And P7 is generating, visualizing, and reading figures and graphs. P1 is translate, formulate, understanding. Oh, this one is on, equations. And this is TIMS data, same attribute analysis. And I did a fact analysis and found out that, geometry goes with P9, P3, S7. S7 is proportional reasoning. P5 is logical reasoning skills. P9 is executive control, the same as, before 9. So that it's obviously geometry. If kids learn geometry at 7th grade, they are going to bypass, honor student and advanced student and get highest, most large number of process skills they master. And conclusion is it's just repeating, same thing. But I think children have to study geometry in 7th grade or 6th grade young enough. Then their thinking skills are going to improve a great deal. And one of my graduate students at Teachers College did a thesis work, TIMS, 12th graders, mathematical thinking skills and geometry, and his result shows backing up this result. And also, I'm reading, lots of neuroscience research paper in music and emotions, and found out that in order to be a winner of piano contest, those pianists, they got to start, they're all, learning piano around 3 years old. So that if late or even 5 years, nobody ever, win. And it's neuroscience sort of proved that why. So I think from this data, I say kids have to learn proofs, proving, those simple, geometric relationships, and proofs. That gives lots of thinking skills to be developed and well, and maintains well until, adult life. So I think this is what algebra, don't assign young kids to algebra, assign to geometry class when they are young, 6th, 7th, 8th grades. That is the conclusion.